This is WLAN smart roaming. And here is the objective. So describe the basic concept of the smart roaming and the least application of smart roaming. Describe the process of the smart roaming, and the last one, we're going to show you the configuration of smart roaming. So let's go to the first content here, the overview of the smart roaming. So we need to understand what is the roaming. So the roaming means is the previous STA they associate with the AP, and then when they roam to another area, then the STA will connect with the new AP. So this is the process of the roaming. So from here, they say during the roaming, STA disconnect from the originally associated AP and associate with the new AP. So the roaming process is initiated by the STA. So all is done by the PC itself, our terminal. Smart roaming is also a process of the STA roaming. However, the process of the smart roaming is initiated by the AP. So they have two different ways here for perform the roaming. If the roaming is done by the terminal, so this is also one of the roaming we call. But for the smart roaming, will be performed by the AP itself. So why the smart roaming is needed? So the sticky terminal have a low roaming aggressiveness. So the meaning here is the PC will always stick to the current associated AP. So no matter how far that you try to go, as long as you can still able to associate with the previous AP, you always connect to the previous one. Even for another AP, they can give you the better signal strength. So this is happening to the terminal when they don't support the smart roaming. So after we enable the smart roaming, so the AP and the STA itself, you try to check based on the signal strength. If the next neighboring AP can able to provide the same SSID but with the better signal strength, the STA will going to connect to the new AP. And here is the benefit for the smart roaming. So after we enable and configure the smart roaming, so the system will actively steer the terminal to the neighboring AP with the better signal. So this is what we want to see. So they also bring you some of the benefit like improve the performance. So this is for sure because the better signal strength, they are able to increase your performance. Okay, the common coverage scenario and also include some of the high density coverage scenario. And of course for the traffic load balance here. Content number 2. Process of smart roaming. So here is the flowchart for the smart roaming. At the beginning, the AP will identify the 802.11k and also the 11v. So they will check on the sticky terminal, the SSSTA. So whether the STA support the 11k or not. So if yes, the process will move to the left. So trigger the 802.11k base measurement. The 802.11k is belong to one of the technology is used by the RRM. Okay, they can able to detect the radio resource and do the measurement. So for the terminal can support the 802.11k, the AC will start to check with every single AP. They can able to connect it with the terminal. So they try to check with every single AP and choose the AP can able to provide the better signal strength to the terminal. So right now they already know which AP can able to provide the better signal strength to the client. Now they're going to proceed to the next step. Does a terminal support the 802.11v or not? So this is another standard. So this one must be checked whether the terminal can support or not. When the terminal is not support, so the current AP rack, you try to force the current terminal to connect. When the AP1 is ready, send the this terminal into the blacklist. That means this current terminal cannot connect to the AP1 anymore. But no need to worry because the AP2 still able to connect associate with the current terminal. So this is how they actually form the rooming. So they will force the terminal trying to connect to the AP number 2. It still connect to the AP number 1. So this only happens when the SDN doesn't support the 802.11v. If yes, it will going to steal the terminal to connect to the new AP instead of the previous AP they connected. Okay, they're either using one way to force the SDN to connect to the new AP. And the case will happening when the terminal doesn't support the 802.11k, the terminal, the PC itself. So when they don't support, that means the AC and the AP rack, they can't able to keep track and all the statistics they come from a client. So what they can able to do here is they're going to check whether right now the AP rack is already enabled the scanning mode or not. Okay, the air scanning, we have to enable this one on the AP. So if we doesn't enable the air scanning mode in the AP, so you automatically trigger the blind hangover. That means they're going to temporarily stop the AP connect with the client and see whether the client will associate with the new AP or not. Alright, so if yes, if the AP really enable the scanning mode, so the AC will select the better AP for the terminal. So they do the same way for the terminal which can able to support the 802.11k. So you try to choose the better signal strength. So after that, they know right now the AP2 can provide the better signal to the current terminal. So they'll force the AP1 send the associate message to the SDA. So the SDA only can connect to the AP2 by this way. So here we identify some of the standards just now that I mentioned, the 802.11k. So the 802.11k provide the radio resource measurement, as I mentioned, the RM. So they can able to measure all the content, include the terminal statistics, the hidden node, the channel load, and also the rooming measurement. So this is happening to the standard here. For the 802.11v, so this one is allowed. This is one of the management protocol, and they allow the AP or the AC to do the management of the current terminal. So if the terminal can support the 802.11v, so this terminal they will follow the fast rooming and room to the better signal strength AP. So this is very important. So the smart rooming feature exploits the terminal management capability of the 802.11v that enable the network side to steer the SDA to specified AP. So for all the AP, they have a certain coverage range. So during the wireless network planning, the edge of the SNR need to be designed for each AP at the coverage edge. So on the roadmap here, first showing an AP periodically check the SNR of its associate terminal. So does the terminal SNR remain lower than the specific SNR in 3 consecutive detection period? If yes, the associate terminal is the sticky terminal. If no, then this not belong to the sticky terminal. So they're using this one to identify right now this terminal is the sticky one or not. So this is the measuring neighboring APs. The AP will try to detect whether the current connect SDA supported the 802.11k or not. If yes, the AP will trigger the 802.11 base neighbor measurement for the terminal. So AP will collect the neighboring AP information, include the MAC address of the AP, the signal strength, and also the channel information, because they want to do some measuring. So they need to know which AP can able to provide a better signal to the terminal. So for the for those of the non-802.11k terminal, what will happen? So the AP will proactively switch the channel to listen the frame of the terminal and try to collect the terminal information. This is happening to those devices that doesn't support it. So the AP will also detect the SNR of the terminal that are not associated with it and periodically report the information about the terminal. Most SNRs exceed the start SNR threshold. Because when the terminal doesn't support the 802.11, the only way the AP can able to capture all the identity from the SDA rack is try to scan all the single channel and try to capture every single frame they send from the SDA. They're trying to understand the SDA. So this is happening for the terminal can support the 802.11k. Starting, they're going to identify the sticky terminal and start to trigger the 802.11k base measurement. So they need to make sure the SDA can support the 802.11. So are there a delay sensitive service? Okay, this is very important. So when you want to doing the what we call smart roaming over here, when there is the delay sensitive service, then the smart roaming cannot deploy in this scenario. Okay, because when you perform the roaming, in certain scenario, this is a scenario they have the delay sensitive, so you might cause some of the interruption. So that's why if yes, normally they don't trigger the SDA for the roaming. Okay, they rather the connection signal strength is very weak. They just don't want to get interrupt. So this is the reason why they don't want to trigger the roaming here. So when there's no any delay sensitive service, then you can process to the next. So select the AP that meet the threshold different requirement. So over here, the requirement right for the threshold, we can able to configure that. Okay, filter out those AP that do not meet the CAC requirement. Then filter out the AP that does not meet the load balancing requirement. Okay, when the AP right is not in the load balancing, so they can able to perform the roaming here. Then the last one, they're going to select the AP right with the strongest signal as the target AP. So they always throw the SDA right to the better signal strength AP, because this is the purpose of the smart roaming. And this is the case when happening to those of the non-802.11k terminal. So they try to identify the sticky terminal. So are there the delay sensitive service or not? So this is very important. So when they have the delay sensitive case, normally they don't do the rooming here. When there's no, then they proceed to the next step. Is a channel scanning enabled on the AP? Because right now, the terminal doesn't support the 802.11k. So that means the terminal is not going to send any information to the AP. So the AP won't know what's going on